Most people believe time started at the same moment for everything, but that's not quite right. Our universe is approximately 13.8 billion years old, a number calculated through observations of cosmic background radiation. But here's the strange part. Time itself didn't exist before the Big Bang. Before that cosmic explosion, there was no before to speak of. Space and time are woven together into something physicists call spacetime. And this fabric literally erupted into existence about 13.8 billion years ago. Before that moment, the very concept of time has no meaning in our current understanding of physics. Time actually runs at different speeds. Einstein's groundbreaking theory of relativity revealed something mind-bending. Time is not constant everywhere. The closer you are to a massive object like Earth, or the faster you move through space, the slower time passes for you compared to someone else. This isn't science fiction. It's been measured and verified countless times. Astronaut Scott Kelly spent 340 days aboard the International Space Station and returned to Earth approximately 5 milliseconds younger than his twin brother Mark. If a spacecraft could travel near the speed of light, the difference would be far more dramatic. A space traveler could age just a few years while decades, or centuries, pass on Earth. Gravity literally bends time and space. Massive objects don't just sit there in space. They actually warp the fabric of reality around them. Planets curve space-time the way a bowling ball creates a dip in a rubber sheet. This warping is what we experience as gravity, and it has profound consequences. Near a black hole, where gravity is impossibly strong, time moves incredibly slowly. An observer far away would see a clock positioned near a black hole, ticking slower and slower as it approaches the event horizon, never quite reaching the boundary from their perspective. Yet someone falling into the black hole wouldn't notice anything unusual as they crossed that invisible line. Black holes guard the deepest mysteries. A black hole is one of the most extreme objects in existence, a region of space so dense and so compressed that gravity prevents even light from escaping. The boundary of no return is called the event horizon. Once anything crosses this boundary, it's gone forever from our observable universe. Nothing can escape from inside the event horizon. No matter, no radiation, not even information itself. At the center of every black hole lies what physicists call a singularity, a point where space-time curves infinitely, and our current laws of physics completely break down. Most galaxies, including our Milky Way, have supermassive black holes at their centers. Our galaxy's black hole, Sagittarius A, is 4 million times more massive than our Sun. Everything you see is stuck in the past. Here's a disturbing fact. You are never seeing the present moment. Light takes time to reach your eyes, so everything you observe is always in the past. The sunlight hitting your face right now left the sun over 8 minutes ago. When you look at stars, you're seeing them as they were years or even centuries in the past. The nearest star to Earth, Proxima Centauri, appears to your eyes exactly as it was over 4 years ago. More philosophically, physicists debate whether now even exists. Your brain also doesn't perceive events until roughly 80 milliseconds after they occur, meaning there's always a gap between reality and your conscious awareness of it. In a real sense, you're always living in yesterday. Your brain experiences time differently than a clock. Time isn't just a measurement on a wristwatch. It's deeply personal and subjective. How fast time seems to pass depends on memory, emotion, and attention. When you're experiencing something new and unfamiliar, your brain encodes many memories, and those experiences feel longer in hindsight. This is called the oddball effect. As you age and accumulate more familiar experiences, more of life becomes routine. Your brain doesn't encode as many distinct memories, so time feels like it's flying by. A year in childhood, packed with novel experiences, seems longer than a year in adulthood filled with routine. This reveals something profound. Time perception is not absolute, but woven into the fabric of consciousness itself. Wormholes might exist, but probably won't help you. Science fiction loves wormholes as shortcuts through space, but the reality is far more complicated. Theoretical physics allows for structures called wormholes, hypothetical tunnels through space-time connecting distant points. The mathematics suggests they could exist, but there's a catch. They would collapse instantly unless stabilized by exotic matter with negative energy density. Scientists have never observed or created such material. Even if a stable wormhole existed, traveling through one might require traveling backward in time, which introduces all sorts of paradoxes. Wormholes aren't practical portals through the cosmos. They're mathematical curiosities that may never become anything more than theoretical constructs. The arrow of time has a mysterious origin. Physics has a strange asymmetry. The fundamental laws don't care whether time moves forward or backward. Yet in our everyday experience, time has a clear direction. You remember the past. You can't remember the future. Broken cups don't reassemble themselves. This directional quality is called the arrow of time. Scientists believe this arrow emerges from entropy, a measure of disorder in a system. The universe started in an incredibly ordered state immediately after the Big Bang with extremely low entropy. Since then, entropy has been increasing, meaning everything becomes more disordered over time. This natural tendency toward chaos and disorder is why the universe looks different in the past compared to the future, and why time has a direction at all. Galaxies collide in cosmic slow motion. On cosmic timescales, galaxies drift through space like ships in an infinite ocean. Our Milky Way and the nearby Andromeda galaxy are currently moving toward each other across the darkness. In about 4 billion years, these two massive galaxies will begin to merge. The night sky will look dramatically different as the structure of space near us undergoes a cosmic reorganization. Stars will be scattered into new configurations, and the two galaxies will become one. This collision won't destroy our solar system. Space is so vast that individual stars rarely collide even when galaxies merge. But the geometry of the night sky will transform completely, a reminder that even the largest structures we can observe are in constant motion and change on timescales that dwarf human civilization. Time and space might not be fundamental. Some physicists and philosophers propose something even more radical. Perhaps time and space aren't fundamental features of reality at all. Maybe they emerge from something deeper, something more basic that we don't yet understand. Quantum mechanics introduces additional layers of strangeness. Particles can exist in multiple states simultaneously, and objects can be entangled across vast distances. Some theoretical physicists suggest that space-time itself might be quantized, made up of tiny, indivisible units rather than being smooth and continuous. If time and space are constructed from something more fundamental, then our entire understanding of reality is just scratching the surface. The universe may be operating according to rules far stranger than our everyday experience suggests, and we're only beginning to uncover what lies beneath.